Earth is accompanied by one natural satellite as it makes its yearly orbit around the Sun. This is the Moon, whose phases mark our months, and whose tidal pull has slowed Earth's spin period from an original 6 hours to its present 24. The Moon is a dry, dead ball of rock about 1/4 the size of Earth. It is locked to Earth in a synchronous spin mode, meaning it completes one spin on its axis in one orbit of Earth. As a result, the same lunar hemisphere always points toward us. The Moon's weak gravity means it has a negligible atmosphere. The vast majority of water released from its interior has evaporated into space. With no blanketing atmosphere, the surface temperature varies at the equator by some 536 degrees Fahrenheit between day and night. Astronomers think that a Mars-sized asteroid hit Earth just after our planet had differentiated into an iron core and a rocky surface mantle. The collision blasted hot rock out of the surface, and this formed into a ring of material around Earth. This material slowly came together to form a world of its own in orbit around Earth. This hypothesis explains why the Moon is iron-poor and why it started life much closer to Earth than it is now. It also explains why its outer shell became a magma ocean and lost many volatile elements. The Moon follows an elliptical orbit around Earth. At its most distant, it is 10% further away than at its nearest point. Its orbit is inclined to the plane of Earth's orbit by just over 5 degrees. The Moon orbits in the same time it takes to spin once, about 27.3 days. At the Moon's surface, there is no wind, water, or weathering. There is just rock. Over time, it has been cratered by the impact of asteroids and meteoroids. The impact rate was highest about 4 billion years ago and has been steadily decreasing ever since. When the Moon was hotter, just below its thin crust, there was a region of molten magma. Large craters penetrated this crust, and the magma flowed over the surface, filling low-lying areas with dark basaltic lava. These became the lunar maria, or seas. The Montes Apenninus is a mountain range 373 miles long. It forms part of the rim of Mare Imbrium, the Sea of Showers. The highest peak rises 3 miles above the floor of the mare. Copernicus is one of the most striking craters on the Moon. The low angle of sunlight emphasizes its terraced walls and central peak. Impact craters like Copernicus and Reinhold reveal billions of years of bombardment history written on the lunar surface. The Moon's crust is made of calcium-rich granite-like rock. The mantle is rich in silicates. Moonquakes indicate the interior structure. The Moon has a solid outer core and a small inner core, much smaller relative to its size than Earth's core. The Moon has been a target for exploration since the space age began. Luna 3 captured the first images of the far side in 1959. Apollo 11 landed the first humans in 1969. Apollo 17 carried the last astronauts to walk on the Moon in 1972. The Moon is our closest space neighbor and appears to be the largest object in the night sky. It keeps the same face toward us at all times, and through reflected sunlight, we see varying amounts of this face over a 29.5-day cycle. Rather than seeing 50% of the Moon's surface, we actually see 59%. This phenomenon is called libration. It occurs because the Moon follows an elliptical orbit, moving faster at perigee and slower at apogee, allowing us to peak around one limb and then the other. The Moon has no light of its own, but it is illuminated by the Sun. When one half is in sunlight, the other half is in darkness. Viewed from Earth, the Moon's disk seems to assume a different shape from day to day, as a changing amount of the side we see is bathed in sunlight. A complete phase cycle takes 29.5 days. During the first half, the Moon appears to grow or wax until it is fully lit at full moon. That is when the Moon sits on the opposite side of Earth from the Sun. During the second half of its cycle, the Moon appears to shrink or wane until it is completely unlit at new moon. That is when the Moon sits between Earth and the Sun. The waning cycle mirrors the waxing cycle in reverse. The moon is called gibbous when it is between half and fully lit, and crescent when between new moon and half lit. At first quarter, it has completed a quarter of its cycle. At last quarter, a quarter remains. The distance between Earth and the moon varies as it follows its elliptical orbit. At perigee, the moon is 10% closer and appears noticeably larger. At apogee, it appears smaller. This difference becomes significant during solar eclipses. The moon and sun appear the same size in our sky. By extraordinary coincidence, though the moon is 400 times smaller than the sun, it is also 400 times closer to Earth. When all three align, the moon's disk perfectly covers the sun. Anyone standing in the darkest part of the moon's shadow sees a total eclipse of the sun. Those in the lighter part see only a partial eclipse. The period during which the sun is completely obscured is called totality, and it lasts just a few minutes. A lunar eclipse occurs when the sun, Earth, and moon are lined up and the moon moves into Earth's shadow. The moon does not disappear completely, but takes on a deep red color, as some sunlight bends through Earth's atmosphere and reaches the lunar surface. A commonly reported phenomenon is that the moon seems larger near the horizon than high in the sky. This is an optical illusion. Our brain is tricked because the horizon moon is seen against a close foreground, while the higher moon is seen against the empty void of space. From the rhythmic waxing and waning of its phases to the rare spectacle of a total eclipse, the moon's dance through our skies has captivated humanity for millennia. It remains our closest companion in the vast darkness of space. The first maps of the moon were little more than sketches recording the dark and light regions on the side of the moon facing Earth. Detail was added once telescopes were turned toward the moon. In recent years, spacecraft have been used to make detailed maps of the entire lunar surface. Early printed maps recorded the view seen through telescopes and introduced Latin names for surface features. The dark areas were thought to be water and were called mare, meaning sea. Lighter regions included mountain ranges called Montes. This naming system is still in use today. Two influential maps were produced in the mid-17th century by astronomers Johannes Hevelius and Giovanni Riccioli. Riccioli's map introduced the Latin naming system that astronomers still use to identify craters, seas, and mountains on the moon. When the United States embarked on the Apollo project, mapping the moon became a serious endeavor. 5 lunar orbiter missions photographed 99% of the lunar surface, resolving features as small as 60 meters across. Lunar mapping in the 1960s was so accurate that in 1969, the Apollo 12 module landed within easy walking distance of the robotic Surveyor 3 craft, which had landed 2 years earlier. The surface of the moon is rough, like Earth's. The height range between its highest mountain and lowest valley is about 12 miles. Laser altimeters on orbiting spacecraft such as Clementine and the Lunar Reconnaissance Orbiter plot surface irregularities with extreme precision. Topographic maps use colors to distinguish between high and low regions. The moon's highest regions occur on its far side. Its deepest depression is the South Pole Aitken Basin, one of the largest impact craters in the entire solar system. When comparing maps of the near and far sides, it is immediately apparent that the two sides are very different. The near side has large dark maria, while the far side is almost entirely covered in bright cratered highlands. Lunar maps can also show invisible features. The moon's gravity tugs unevenly on orbiting spacecraft. By measuring the way orbits deviate from perfect ellipses, astronomers can model how the density of lunar material varies beneath the surface. Maps also reveal the distribution of iron on the lunar surface. The near-side maria are rich in iron-bearing basalt from ancient lava flows. The far-side highlands contain much less iron, reflecting the differences in geological history between the two hemispheres. Among the most famous mapped features are Mare Tranquillitatis, where Apollo 11 landed in 1969, and the spectacular Tycho crater, with its bright ray system stretching hundreds of miles across the southern highlands. From the earliest sketches by hand to laser altimeters orbiting hundreds of miles above, humanity's mapping of the moon has grown ever more precise. Each new mission reveals more secrets hidden beneath the familiar face of our nearest neighbor. The moon's surface is a record of billions of years of bombardment. Without wind, water, or weathering, every impact leaves a permanent scar. The surface is covered with craters of every size, from tiny pits to massive basins hundreds of miles wide. When the moon was young and hotter, molten magma lurked just below its thin crust. Large asteroid impacts punched through this crust, and magma flowed across the surface, filling low-lying areas with dark basaltic lava. These smooth, dark regions are called maria, or seas. The Montes Apenninus is one of the most impressive mountain ranges on the moon. Stretching 373 miles long, it forms part of the rim of Mare Imbrium, the Great Sea of Showers. Its highest peak towers 3 miles above the mare floor. Mare Imbrium, the Sea of Showers, is one of the largest basins on the moon. It was formed about 3.8 billion years ago when a massive object slammed into the surface. The impact was so powerful that it created the ring of mountains we see today. Copernicus is one of the most striking craters on the lunar surface. About 60 miles across, it features beautifully terraced inner walls and a prominent cluster of central peaks. The crater is surrounded by bright rays of ejected material that extend hundreds of miles in every direction. The low angle of sunlight on the lunar surface emphasizes the beauty of craters like Copernicus and its neighbor Reinhold. These shadows reveal the true depth and complexity of impact features that would otherwise appear flat when viewed from directly above. Tycho is a relatively young crater, only about 108 million years old. It is easily recognized by the spectacular system of bright rays that extend across much of the moon's near side. These rays are made of pulverized rock thrown out by the impact. The impact rate on the moon was at its highest about 4 billion years ago, during a period called the Late Heavy Bombardment. Since then, impacts have steadily decreased. Today, you would need to observe the moon for about 40,000 years to see a new crater larger than half a mile across. The moon's far side, which can never be seen from Earth, is dramatically different from the near side. It is almost entirely covered in craters with very few of the dark maria that dominate the near side. This asymmetry remains one of the great mysteries of lunar science. The moon's internal structure has been revealed through moonquakes detected by seismometers left on the surface by Apollo astronauts. The moon has a thin crust of calcium-rich rock, a thick silicate mantle, and a surprisingly small iron core at its center. The moon's atmosphere is essentially non-existent, containing only about 25 tons of trace gases. These come from radioactive decay within the rocks, meteoroid impacts that release gas, and solar wind particles captured by the surface. The moon has no light of its own. It shines only because its surface reflects sunlight. At any given moment, one half of the moon is bathed in sunlight while the other half sits in darkness. As the moon orbits Earth, we see different amounts of its sunlit side from our vantage point on the surface. These changing shapes are called the phases of the moon. A complete phase cycle takes 29.5 days. The cycle begins with the new moon, when the moon is positioned between Earth and the sun. At this phase, the entire sunlit side faces away from us, and the moon is essentially invisible in our sky. After new moon, a thin sliver of light appears on the right side. This is the waxing crescent phase. Each night, the illuminated portion grows larger as the moon appears to wax or increase in size. When exactly half of the moon's visible face is illuminated, we have reached the first quarter phase. The moon has completed 1/4 of its full cycle. At this stage, the moon rises at noon and sets around midnight. Between first quarter and full moon lies the waxing gibbous phase. The word gibbous comes from Latin meaning humpbacked. More than half of the moon's face is now illuminated, and it continues to grow brighter each night. The full moon occurs when the moon is on the opposite side of Earth from the sun. The entire visible face is illuminated, creating the brightest and most spectacular moon of the cycle. Full moons have inspired myths and legends across every culture. After full moon, the illuminated area begins to shrink. The moon is now waning. The waning gibbous phase shows a moon that is still mostly bright, but losing illumination from the right side each night. At last quarter, the moon is again half illuminated, but now the opposite half from first quarter is lit. The moon has completed 3/4 of its cycle. It now rises at midnight and is visible in the morning sky. The waning crescent is the final phase before a new cycle begins. Only a thin sliver of light remains on the left side. The old moon grows thinner each morning until it finally disappears at the next new moon. The moon appears to be the largest object in the night sky, but its apparent size actually changes as it follows its elliptical orbit. At perigee, when closest to Earth, the moon appears 10% larger than at apogee, its most distant point. From waxing crescent to full moon and back through waning crescent, the lunar phase cycle has marked time for humanity since the earliest civilizations. Our word month comes from moon, reflecting this ancient connection between the lunar cycle and human timekeeping. The moon and the sun appear to be roughly the same size in our sky. This is an extraordinary coincidence because although the sun is 400 times larger than the moon, it is also 400 times farther away from Earth. A solar eclipse occurs when the sun, moon, and Earth are directly aligned and the moon passes between Earth and the sun. The moon's disk covers the sun's disk and blocks it from view, casting a shadow on Earth's surface. When the moon is at perigee, its closest point to Earth, it appears large enough to completely cover the sun, creating a total solar eclipse. Anyone standing in the darkest part of the shadow, called the umbra, experiences totality. During totality, the sun's corona comes dramatically into view. This ghostly white halo of superheated gas extends millions of miles from the sun, but is normally invisible, hidden by the overwhelming brightness of the solar surface. For a few magical seconds at the beginning and end of totality, sunlight floods between mountains on the moon's limb, creating the spectacular diamond ring effect. A single brilliant point of light blazes against the corona, like a jewel on a ring. Those standing in the lighter outer shadow, called the penumbra, see only a partial eclipse. The moon covers just part of the sun, leaving a crescent-shaped bright area. Partial eclipses are visible over a much wider area than total eclipses. When the moon is at apogee, farther from Earth, it appears slightly smaller than the sun. During an eclipse at this distance, a bright ring of sunlight remains visible around the moon. This is called an annular eclipse, from the Latin word for ring. A lunar eclipse occurs when Earth passes between the sun and the moon. Earth's shadow falls on the moon, darkening it. The moon does not completely disappear, but turns a deep, dull red color during totality. The moon turns red during a lunar eclipse because a small amount of sunlight passes around Earth and is scattered by our atmosphere. The atmosphere filters out shorter blue wavelengths, leaving only the longer red wavelengths to reach and illuminate the moon. Unlike solar eclipses, which can only be seen from a narrow path on Earth's surface, lunar eclipses are visible from anywhere on the nighttime side of our planet. This means they are far more commonly observed than solar eclipses. Eclipse seasons occur roughly every 6 months when the moon's orbital plane intersects the line connecting Earth and the sun. Because the moon's orbit is tilted 5 degrees, eclipses do not happen every month, but only during these special alignment windows. From the diamond ring of a total solar eclipse to the blood-red moon of a lunar eclipse, these celestial alignments have awed and terrified humanity for thousands of years. Today we understand the precise mechanics, Yet, eclipses remain among nature's most spectacular events. The first maps of the moon were little more than sketches recording the dark and light regions visible from Earth. Early observers could see that the moon's face had distinct patterns, but they had no way to understand what these features truly were. Once telescopes were invented and turned toward the moon, much more detail could be recorded. The dark areas were thought to be bodies of water, so they were called maria, the Latin word for seas. Lighter regions included mountain ranges, called Montes. Two of the most influential early lunar maps were produced in the mid-17th century by astronomers Johannes Hevelius of Danzig and Giovanni Riccioli of Bologna. Riccioli introduced the Latin naming system that is still used today. Riccioli named the Dark Maria after weather and moods. Mare Tranquillitatis became the Sea of Tranquility, Mare Imbrium the Sea of Showers, Oceanus Prosolarum the Ocean of Storms. These poetic names survive unchanged after nearly 4 centuries. When the United States embarked on the Apollo program, mapping the moon became critically important. 5 lunar orbiter missions photographed 99% of the lunar surface, revealing features as small as 60 meters across. The lunar orbiter photographs were remarkable achievements of engineering. The films were developed on board the spacecraft, and the images were then scanned and transmitted back to Earth as electronic signals. 20 potential Apollo landing sites were studied in extraordinary detail. Lunar mapping in the 1960s was so precise that in 1969, the Apollo 12 module landed within easy walking distance of the robotic Surveyor 3 spacecraft that had landed 2 years earlier. This pinpoint accuracy was a triumph of cartography. The near side of the moon is dominated by large dark maria, interspersed with lighter highland regions. Small bright spots mark geologically recent impact craters surrounded by freshly ejected material that has not yet been darkened by space weathering. Mare Serenitatis, the Sea of Serenity, and Mare Tranquillitatis, the Sea of Tranquility, are 2 of the most prominent features on the near side. Mare Tranquillitatis is famous as the landing site of Apollo 11, where humans first walked on the moon. Mare Crisium, the Sea of Crises, sits alone on the eastern limb of the moon. Its isolation makes it one of the most easily recognizable features, even with the naked eye. This dark oval basin is about 340 miles across. Petavius is a large crater near the moon's southeastern limb, about 110 miles across. It features a prominent central peak and a distinctive crack, or rilla, running from the peak to the crater wall. Such features hint at the geological forces that shape the moon. From the earliest hand-drawn sketches to spacecraft photography, resolving details just meters across, our maps of the moon have transformed over 4 centuries. Today, every crater, mountain, and rill on the lunar surface has been charted with remarkable precision. Beyond photographs, scientists have mapped invisible features of the moon using specialized instruments aboard orbiting spacecraft. These maps reveal secrets hidden beneath the surface, including variations in density, gravity, and mineral composition. The surface of the moon is rough, much like Earth's. The height difference between its highest mountain and lowest valley is about 12 miles. Laser altimeters on orbiting spacecraft precisely measure these elevation changes by bouncing light off the surface. The Clementine spacecraft orbited the moon in 1994 and produced detailed topographic maps. In these maps, the relief is exaggerated to better show the relative heights of surface features. False color gives further emphasis to the terrain. The Lunar Reconnaissance Orbiter has been mapping the moon since 2009 with unprecedented precision. Its laser altimeter has produced elevation maps with a resolution of just a few meters, revealing every small crater and ridge. The moon's highest regions occur on its far side in the center and north. Its deepest depression, the South Pole Aitken Basin, is also on the far side. This basin is one of the largest known impact structures in the entire solar system. When comparing maps of the near and far sides, it is immediately apparent that the two sides are very different. The near side has large, smooth maria, while the far side is almost entirely heavily cratered highland. Scientists are still debating why this dramatic asymmetry exists. The moon's gravity is not uniform. It tugs unevenly on orbiting spacecraft, causing their paths to deviate from perfect ellipses. By precisely measuring these orbital changes, scientists can map how the density of lunar material varies beneath the surface. Lunar Prospector produced detailed gravity maps revealing concentrations of dense material called mascons beneath the surface. These mascons are associated with the large impact basins and are shown in red on gravity maps. They represent the densest regions of the moon. Magnetometers aboard spacecraft have also discovered regions where the lunar magnetic field is enhanced. These magnetic anomalies, called magnons, have been mapped across the surface. Their origin remains a subject of ongoing scientific investigation. Clementine's ultraviolet and infrared cameras collected data that revealed the iron content of the lunar surface. Areas with increased iron tend to be in the lava-filled maria, confirming that these dark regions are made of iron-rich basaltic rock. The contrast between the near and far sides extends to their iron content. The near side maria are rich in iron from ancient lava flows, while the far side highlands contain much less iron. This chemical asymmetry adds another layer to the mystery of the moon's two faces. From elevation to gravity to iron content, invisible maps have transformed our understanding of the moon. Each new mission adds another layer of data, revealing that our nearest neighbor is far more complex and fascinating than its gray appearance suggests.